All right, let's take a look at the transport of respiratory gases. So we're going to start this off looking at oxygen transport. So most of our oxygen is transported by hemoglobin. Only a small amount, 1.5%, is transported by the plasma itself. So let's look at oxygen and hemoglobin. All right, hemoglobin has 4 binding sites for oxygen. So each of these heme groups is one of those binding sites. All right, and so when all 4 heme groups have oxygen, this hemoglobin is said to be fully saturated. When the first oxygen binds to a heme on the iron on the heme, this is going to change the shape of the hemoglobin molecule, which makes it easier for the second, third, and fourth oxygen molecules to bind. So if only 1, 2, or 3 of these hemoglobin if only 1, 2, or 3 of these heme groups have oxygen, we say that this hemoglobin is partially saturated. If a hemoglobin unloads an oxygen molecule, it's also then it makes it easier to lose the second, third, and fourth oxygens as well. So when we look at arterial blood is 98% saturated, while venous blood is 75% saturated. So we still have a lot of oxygen in our blood, even in the veins. Let's look at influences on this. So if we kind of move to this picture here, if we have an increase in either temperature, carbon dioxide concentration, or hydrogen ion content, all will decrease hemoglobin's affinity for oxygen, meaning it's going to release more oxygen out of from that hemoglobin molecule. And so this increases what we call oxygen unloading. Coincidentally, we talked about this before. Carbon dioxide and hydrogen ion concentrations are kind of linked here, because if you mix carbon dioxide right here with water, produces carbonic acid. And carbonic acid, is an increase in hydrogen ion concentrations, or acidity, right? So where is acidity highest? Well, it's highest by body cells, because body cells are releasing carbon dioxide. And so if we increase acidity, well, that's going to increase hemoglobin releasing oxygen molecules in that area. So it kind of works really well together. Increase carbon dioxide, increases acidity, we release more oxygen in that same area, which is right by body cells. Let's look at hypoxias now. Hypoxia is an inadequate delivery of oxygen to the body tissues. And this can result in a cyanosis, which is a blueness of the skin. So looking at different kinds of hypoxias, the first is an anemic hypoxia, and that's where, or also known as anemia, and that's where you have few red blood cells or little hemoglobin in those red blood cells, so you can't transport a lot of oxygen that way. Next is ischemic hypoxia, or also known as ischemia, and here your blood circulation is impaired or blocked, like what could have happened in a heart attack. Next is a histotoxic hypoxia, and here the blood cells are unable to use oxygen even with adequate amounts of oxygen. And this is a typical result of being exposed to a poison or a toxin. All right. Next is a hypozemic hypoxia. This is a reduced arterial concentration of oxygen. This is due to imbalances in ventilation perfusion coupling, so where you're getting air into your lungs, mixing with the blood flow isn't working, or you have low oxygen in the air or problems with ventilation. So this would be somebody who has emphysema who would have issues with hypozemic hypoxia. Next is carbon monoxide poisoning. It is a type of hypozemic hypoxia. And so with carbon monoxide poisoning, carbon monoxide actually competes with oxygen for the heme group. All right, so these binding sites. So, and the problem here is that hemoglobin has more affinity for carbon monoxide than it does for oxygen, about 200 times more. So even low amounts of carbon monoxide can lead to carbon monoxide poisoning because it doesn't take much. All right, and this is why we should all have carbon monoxide detectors in our homes to see if our furnaces are working correctly or not. Lastly is oxygen toxicity. So oxygen toxicity. This is the breathing of pure oxygen for a few hours. And what this does is it produces hydrogen peroxide. And hydrogen peroxide can be a poison to us, and it can damage enzymes and nervous tissue, and it can lead to seizures and even death. All right, so let's look at carbon dioxide transport, and I really don't have a slide for this, but all of our body cells produce carbon dioxide. As long as our body cells are alive, we're going to constantly break down glucose. We're going to constantly make carbon dioxide as a byproduct. So if we take all of our body cells together, we make about 200 milliliters of carbon dioxide per minute. Most of this is dissolved in or not most of it, I should say, some of it is dissolved in our plasma, about 7 to 10%. Some is actually bound to hemoglobin, and this is called carboaminohemoglobin. All right, so the carbon dioxide binds to the globin, which is the protein part, and it doesn't bind to the heme, so it's not competing with oxygen there. But most of our carbon dioxide is in the bicarbonate form. And that right there, HCO3, is bicarbonate. All right, so about 70% of it is transported in this way. All right, so, and we go back and forth between, this right here, carbon dioxide with water produces carbonic acid, which then produces bicarbonate and hydrogen ions, and then that going back in the opposite direction, which it does here. All right, next is a Haldane effect. The lower the oxygen concentrations, the more carbon dioxide can be carried in the blood. So if oxygen levels go up, less carbon dioxide can be carried. If oxygen levels go down, more carbon dioxide can be carried. So we do have a carbon dioxide dealing with blood. Kind of talked about this before, but we have the carbonic acid bicarbonate buffer system. This helps maintains our arterial blood pH of 7.4. So going from carbon dioxide and water producing carbonic acid, which then can make carbonic bicarbonate and hydrogen ions, or if we have excess hydrogen ions like we do here, we go in the other direction. All right? One of the ways that we can also regulate this is just by our breathing. So if we have slow, shallow breaths, carbon dioxide accumulates in the blood, and this can increase carbonic acid in our blood, which decreases our blood pH, makes it more acidic. If we increase our respiratory rate, have rapid, deep breaths, we get rid of more carbon dioxide out of our blood, which means we have less carbonic acid in our blood, so our pH goes up, becomes more basic.